Example 7, Chapter 3, Fluid Mechanics. A construction in a pipe will cause the velocity to rise and the pressure to fall at section 2, as shown in this picture. So velocity rise, V increase and P decrease in this section. In the truth, the pressure difference is a measure of the flow rate through the pipe. The smoothly naked down system shown in this figure is called the venturi tube. So we have here a find an expression for the mass flux in the tube as a function of the pressure change. Find in the tube as a function of the pressure change. First, we should write the Bernoulli equation between point 1 and point 2, which is P1 on rho equals to this is a Bernoulli equation with the considering some assumption. It can be obtained provide a appropriate relation between, for example, velocities and pressure. So in this case we have Z1 equals to Z2, so these two components of the relation will be eliminated, and we have this relation for, after simplification, P2 minus P1 on rho equals to minus P2 squared. So we can write minus P1 minus P2 right. If we consider P delta P equals to P1 minus P2, we can write the relation of a venturi device as on rho V1 squared. We relate the velocities from the incompressible continuity relation, and we have for the mass conservation A1 V1 equals to A2 V2. So we can write V1 equals to A2 on A1 V2, and if we consider the an expression for A2 on A1, or the relation for the diameters of the inlet and outlet, as in this case truth. For example, if we define beta equals to D2 on D1, So we can write V1 equals to beta 2 V2. This is a relation between two velocities in the venturi device. So we can simplify the relation. We have two relation, beta 2 equals to and V1 equals to, so, and from the previous relation that obtained from Bernoulli equation, we have also this relation. With replacing to the velocity, we can obtain this relation for V2. Let me write V12 equals to beta 4 V2 square. The result we can replace to this relation V2 square minus beta 4 so we have this relation for V2 square this is the relation for velocity at the truth. M dot equals to, if we want to obtain a relation for the mass flux in the truth, we have to write this relation. So we have the rho A2 multiply to V2 this relation gives us a possibility to calculate m dot according to the density. Again, density, geometry, specification, and pressures, which can be calculated by devices on the venturi instrument. So we with this collecting this data from for example a flow, we can calculate m dot flux, mass flux in the flow.